Today we will be talking about pre-sterilization preparation of material. Why is this important? Because choosing the best sterilization method is one of the most important things when it comes to medical equipment. Using an inappropriate or insufficient method of sterilization can keep your medical equipment from receiving clearance from Food and Drug Administration and other regulatory bodies. At worst, inadequate sterilization can result in the transmission of infectious diseases, and this can lead to patient's illness or death. For instance, in 2015, there is an antibiotic-resistant bacterial infection outbreak and was associated with reprocessed duodenoscopes used for assessing the small intestine in a variety of procedures. And these scopes, they were designed by several medical device manufacturers and were found to have a flawed design, in which kept them from being completely sterile between procedures. And because of this, as many as 400 individuals became infected with so-called superbugs and led to at least 35 deaths. The duodenoscopes manufacturers faced lawsuits and patients and their families impacted by this outbreak, and the FDA made a series of device recalls. So what are the sterilization methods? The first one we can look at is chemical sterilization. These broad chemicals, for example, the one indicated in this blue diagram, these chemicals have the power to kill a broad range of pathogens and have properties that could be very harmful to humans. You can submerge the equipment in the prepared chemical completely for a certain amount of time until the pathogens die. And once it's sterilized, we rinse it, allow it to dry. But chemical sterilization isn't suitable for biological material, fiber optics, and other highly heat-sensitive materials. Here we can see on the first column, the chemical sterilization is used, like for example, perhydrol, hydrogen peroxide 6%, Lysol aldehydes such as formaldehyde 6%, and glutaraldehyde. And for sterilization of suture material, we can and disposable material, sterilized with radiation are more preferred. And also we can use Vicryl, Dexone, Proline, polyglycolic acid, and chemical sterilization using Lugol solution and 96% alcohol these days are nowadays a little bit less practical. On the right side, you can see another diagram of chemical sterilization, in which you see gaseous sterilization and liquid sterilization, and these are the options that we can use for chemical type of sterilization. Next, we'll look at the other methods of sterilizing the medical equipment, which includes steam sterilization or autoclave, dry heat oven, gas sterilization, and ionizing radiation. For steam sterilization, and most sterile processing departments have steam sterilizers called autoclaves, and this is because steam can clean many common medical devices and is typically the safest and cheapest option. Some technicians will only consider using another method when this medical device is made of a heat-sensitive material and cannot be steam sterilized. The autoclave will apply intense pressure and heat to destroy all the microorganisms on the objects. And as you can see, it is only for instruments which is unable to withstand high temperature above 130 degrees Celsius. For the methods of autoclave, my colleague will be discussing about this in another video. Secondly, the dry heat oven with the sterilization indicator. When the steam cannot penetrate an instrument or can destroy it, your next logical option is to use dry heat. And dry heat is a strong but very slow technique requiring high temperatures and time. And because of this, it is not very suitable for many materials, but is still more reliable than various other options. Dry heat sterilization uses an air around 340 degrees Fahrenheit to kill microbial life. As you can see here, it shows how a dry heat oven looks like. Next, we have gas sterilization, and is for instruments intolerant to heat and, for example, fiber optic endoscopes. One of the examples is also plasma gas sterilizers, and this type of sterilization uses low temperature hydrogen peroxide based gas plasma inside a chamber to kill any microorganisms on dental and medical equipment, including spores, bacteria, fungi, and viruses. When you add the vaporized hydrogen peroxide to the chamber, it sterilizes the enclosed equipment, and once you remove the vapor from the chamber, it produces a plasma of a lower temperature which ensures total sterilization for all equipment. Oxygen and water are the remainder of this process and makes these sterilizers safe for both the environment and medical staff. While this is a more costly method, it's extremely effective and an excellent option for medical equipment and tools that are moisture sensitive. Lastly, we have ionizing radiation or G-rays, which requires special equipment and is commonly used by manufacturers to sterilize disposable items like gowns, needles, scalpels, etc. In the context of sterilization, ionizing radiation is a type of short wavelength, high intensity, low temperature radiation that is used to destroy all microorganisms during sterilization. The forms of ionizing radiations used for sterilization are known as gamma irradiation, electron irradiation, and X-ray irradiation.